Let's go over these problems. So the first one, we have a glass rod rubbed with silk, and a positive charge is given to the glass rod. How do things become positive? By losing electrons. So the electrons go to the silk, they leave the rod, so it's by removing electrons from the rod. Okay, the next one says, which diagram represents the direction of an electric field? An electric field is determined by the direction of the force on a positive charge. Well, this is the only one in which a positive charge would move in the direction of the lines, of the arrows. So it must be choice 1. Number 3 says, the current in a wire is 5 amps. So we know the current, and they tell us the total amount of charge is what we're looking for, and they're giving us the time. So we can do I equals Q over T, and we have 5 amps is equal to Q over 36 seconds, and Q comes out to 180 coulombs. Okay, in this one we have an electric field that they give us. Actually, they don't give us the electric field, they give us the force. And they also give us the fact that it's an electron, so that means we know the charge. And they want to know the strength of the electric field. So that is an E equals F over Q. And we don't know E, that's what we're looking for. And we have 1.5 times 10 to the minus 14th newtons divided by the charge on an electron, 1.6 times 10 to the minus 19th coulombs. So E comes out to 9.4 times 10 to the 4th, and that would be in newtons per coulomb. The next question says, which statement describes the gravitational force and the electrostatic force between two charged particles? Well, we know that gravity can only attract, and that the electrostatic force can either attract or repel. So choice 2, gravitational force must be attractive, where electrostatic force can either attract or repel. In this one, we have the electrostatic force between two positive charges, that's key, separated this distance, that doesn't really matter, and the distance is decreasing. So what happens if we move these two closer together? The force will go up, but they're going to be repelling. So therefore, the answer is 4, repulsion, and the two charges, the force goes up because they're getting closer. In this question, they say that the potential difference is 2 volts. What is potential difference? That's voltage. So we're probably going to use V equals W over Q. They want to know the energy. Energy is the work, W. And they give us the charge is 8 times 10 to the minus 19th. So that's 2 volts is equal to W over 8 times 10 to the minus 19th coulombs. And when you do the math on that, you get 1.6 times 10 to the minus 18th joules. And that is choice 2. This one says an isolated conductor is placed in the vicinity of a positive charge. The conductor is attracted to the charge. What could the charge of the conductor be? Well, remember, we can get attraction 2 different ways, by having the opposite charge, or it could be neutral. So that's number 4, neutral or negative. In this question, we have an electroscope, and it says that we bring a positive rod near it, and the motion of the leaves results from electrons moving in which way? Well, if we have a positive rod next to this electroscope, the electrons are going to move up to the top, leaving this positive, so they repel. So what's the motion? Electrons coming to the top. So the answer is 1. They moved from the leaves up to the knob. This last one involves the idea of conservation of charge. So we have 2 spheres. The first sphere has a charge of -6 times 10 to the minus 6 coulombs. and the other one has a charge of plus 2 times 10 to the minus 6 coulombs. So what's the total charge? What's Q total? Well, that's going to be the negative 6 times 10 to the minus 6 coulombs plus the 2 times 10 to the minus 6. So if we touch them, they are going to share that charge. So that Q total comes out to negative 4 times 10 to the minus 6. But that's not the end of the story. That's the net charge on both spheres. So now, to find the Q average, we're going to divide by 2, and that gives us minus 2 times 10 to the minus 6 coulombs.